How you guys doing in here tonight? Everybody's doing good. Everybody's eating their zucchini. Look at that. Nice. All right. What are you doing in here, man?
I'm doing an experiment.
What are you doing an experiment for?
To show how the Aqua-Cave works.
To show how the Aqua-Cave works?
Yes.
Whoa. That's cool, man. All right, what do you got there, dude?
I've got some dry ice.
Which is what?
Which is frozen CO2.
Yeah, carbon dioxide,
Yes.
right?
Yeah.
And why do we have that?
Because it came with the Hungry Planet stuff. It's like to keep it frozen.
Yeah, so they shipped us a bunch of stuff. We're going to be doing a bunch of videos on these new plant-based type of, meats and that.
Yes.
And all kind of different cool stuff. And they
Be
sent us
careful
these.
whenever you're holding this. You gotta have some time protection on because it will burn your skin.
Yes, you got these ovens. So why will this burn your skin as opposed to like the liquid nitrogen snacks that we had? Remember when we were in Orlando recently?
Yes.
That was negative 300. This is only negative 100.
Yes.
So there's not enough of a difference to where it causes that Leidenfrost effect, that layer of gas.
It's so cold, it just doesn't really do anything. But if it's just under it, it actually really hurts.
Right, so there's like a 200-degree difference instead of a 400-degree difference. So if you touch this, it would burn you, give you frostbite,
Yeah.
right?
All right.
All right, so go nice and easy and put this in the water here, see what happens. So this water is about, 120, 150 degrees, like a hot water tank.
It's like the scene from the Gremlins.
So that's about a 250-degree difference, right? Isn't that cool? And you can see what it's doing. That gas is just basically what's happening there. If you blow that out of the way, is that it's turning from a solid immediately into a gas, isn't it?
Yes. There's no.
And what's that called again?
I forget, but it's not.
Starts with an S.
Evaporation.
Sublimation.
Sublimation. Yes.
Yeah. That's just one little piece. Look at these huge pieces they gave us. You want to put more in there?
Yeah, let's go.
Put more. Put it in the next one. Put it in the one next to it. It's frozen. Hold on, let me get it. Oh, there you go.
Oh, it's like sharp.
See if some of that little edge will break off and we'll do some other stuff. Yeah. But no, put the little one down. I want to show them something. Go ahead and put that one in nice and easy. That's going to be a lot of smoke. Now, you can't inhale this because it's carbon dioxide, but if you don't wave it around much, what it'll do is it'll go down. See how carbon dioxide's heavier than oxygen?
Yeah.
Well, oxygen, room air is primarily nitrogen.
Yes.
So you can see here carbon dioxide goes down. Now, the reason that we wanted to talk about this, because a lot of people ask us about our Aqua-Cave, right? So let's go over here into the fish tank room here. This is our Aqua-Cave. And this is one of the questions that people had, and they said when that room air is coming up into the tank, they said if the turtle is in there breathing, they said, won't she then get, a buildup of carbon dioxide? And we explained in the video, didn't we?
Yes.
That's what would happen, right? That the carbon dioxide that she exhales will go down to the bottom.
Yes.
It will be pushed out the hole.
And then go up to here.
And then see how that just burped out and then come out the tank.
Yes.
The fresh air that's coming in, which is about 70 to 80% nitrogen, and then it has oxygen, and so that would push the carbon dioxide out because this is coming in much faster than she is breathing. So that's why she can stay in there all the time in her little Aqua-Cave and have a constant supply of fresh air because the carbon dioxide is heavier and it's at the bottom where the hole is. But the parrotfish keep photobombing. So at the end of the day, this room air is coming in, it is going to the top, it is pushing her carbon dioxide out through this hole, and that's why she can stay in there. People quite often ask us that.
Yes.
And there's your answer. And you can see very easily that carbon dioxide, turns into a gas, and you can see it because it's sublimating, and it immediately goes down to the bottom. Isn't that cool?
That's epic.
So that's the explanation. People were asking for the explanation in the comments a lot of times. They said, the turtle's going to suffocate. I said, no, she very much is not. And that's the explanation. Let's turn the big light off so they can see the colored lights here. Yeah, this looks kind of cool. So if you ever have a Halloween party,
That's the stuff.
Just let it go down instead of waving it around. If you ever have a Halloween party, what you can do is fill your sink full of hot water, get a little dry ice, you know, and you can get it with stuff you order, whatever, and then you can have a color changing light like
That's
that,
cool.
like like we have, and then it'll kind of look neat, huh? Now, what'll happen here? Let me turn this light back
Do not
on.
dip your hand in there, you'll probably die.
Right. Well, right now, if I put my hand in here, it's going to be still pretty warm because I made it really hot.
Yeah.
But that dry ice will actually make that cold pretty quickly, and this won't last very long.
Yeah, don't put it right in there for a long amount of time.
Yeah. What you can do, though, because me and my roommates did this in college, if you have a little party or something, you can actually put a big old, like, soup, big, huge pot, turn the oven on, like, low, put the dry ice in, and then the oven will kind of keep the water warm, and it'll continue to bubble. Isn't that neat? But you can see that it's just turning. If you look at it, it's just turning right into gas. So yeah, you wouldn't really want to wave it around too much. You don't want to breathe it in because it can affect you. But if you let it sit, you can see it kind of go down like that. But anyway, that's cool. That's dry ice, and you can get dry ice from ice places, and you can get them from shipping. Isn't that neat, though, how it then just goes away and it just mixes in with the other air? But anyway, that's the explanation, guys. That's why the turtle can go into the Aqua-Cave and stay in there all day and all night if she wants, because the carbon dioxide is pushed out by the lighter air coming down from the top. And of course, we know it's true because she's 3.5 years old and she's been in there this whole time.
She's pretty healthy.
And she's doing well, so obviously that holds true. But we knew that it would because we understand science, right?
We are smart.
It's all about science. Isn't that cool, guys? Turn the light back off and don't wave it around. And I just want to show what it looks like because it's really neat when you got the changing lights there. Isn't that cool?
I wonder what would happen if I turn the water on a little bit.
And these are very similar to the fish tank lights that we use. They're just little under the cabinet lights. And we have all different kinds that we use. And they have different modes. And you can change the color or whatever. Isn't that cool, though? Yeah, I think we'll wait on that last one. You can also do this if you have a party outside. You can take like a big barrel, fill it full of hot water, or plug in a crock pot or something of that nature. And then that'll do it too. Isn't that neat, though? Let me show them with a little piece. We're going to take a little piece, show them what it does in a spoon. Now, if you just put that spoon on there, go ahead and show them. Just set it on top. Hold the end. There you go. Now, why is that doing that? Why does that vibrate?
That's because the temperature of the spoon is much hotter than the temperature of the ice, so it has the Leidenfrost effect where it creates a bubble.
So it does have a little bit of a Leidenfrost effect. So it's actually those air bubbles. So if you hold it, let me see it. If you kind of hold it,
do it on the other one.
see how it's just kind of vibrating?
Because the air is pushing it up.
You hear that vibrating like that? Now it's cold because it's been on there for a minute. So if we take it and we dunk it in hot water for a second, get it warm again, now watch. I'm gonna put it back on there. It's gonna start vibrating again.
It's so cool.
And you can see that it's kind of like melting away those molecules of ice, and they're sublimating right into a gas. Isn't that neat? Now we'll chip a little piece off. We'll put it inside the spoon. That's even cooler. All right, now Jack's going to take a little piece, going to pick up the scissors, put it in the spoon. Can you get it in there? There you go. Oops. Popped right out, didn't it? Now see it dancing around? That's that Leidenfrost effect. It's basically floating.
It is.
It's basically floating because see how it's sublimating, so that's causing a little layer of gas. So it's actually floating inside of the spoon. Isn't that neat?
Mm-hmm.
If you kind of look at it, you see the gas kind of shooting out from all the sides of it. I'm going to put it under a good light here.
This one's starting to dissipate.
Isn't that cool? Actually, let me set it down and I'll show you. If you get it nice and warm, get the spoon really nice and warm, put it in the warm water, see, it really dances around. See that? Isn't that cool? It's not focusing. There it is. Super neat. And then we put that in there. It's going to do the same thing. So So those are actually gas bubbles coming right off that piece of ice. Let's put it in a glass though so we can see it better. You can see this little piece right here. It's dancing on top of the water because it now weighs so little that Leidenfrost effect is actually keeping it floating on top of the water. So it actually won't touch the water. It's actually floating on top of the water. Isn't that cool? But our hands are not as hot as this water is. And so there's not enough of a temperature to cause that Leidenfrost effect so it would actually burn us. But this water is quite hot compared to our hand. Isn't that neat how it dances like that? Well, when you put a big piece in, it sinks to the bottom because it weighs more, and then there's just gas all around it. We'll show it here in a glass. Isn't that crazy? It's actually moving the molecules. Isn't that great? All right, now you got a smaller piece there, huh?
Yes, I do.
All right, now take that and I'm going to put it in the glass, and then that way you can see that the actual gas. I'm going to blow it out of the way. See how the gas is all around that piece of ice? All right, so you can see that piece of ice is evaporating so quickly, it's not even actually touching the water that it's in. Isn't that crazy? It's making so much. Now, there are people that put these like in their drinks and stuff, but here's the problem.
Yeah.
First of all, we don't know how clean the dry ice is. I mean, it's wrapped in plastic. It's not necessarily food quality.
PPA.
BPA, something in it, right? The other thing is if you touch your lip or something, you could burn it or whatever, right? Isn't that cool, though? Super neat. Yeah, look at that piece of ice. Now, if you're a little wiener dog, like our dogs, then they're gonna be affected by that. But of course, you know, we're gonna keep an eye on them, and we're gonna open the door here in a minute. But so, what are they doing? Are they checking it out?
I don't think they like it.
Hey, come here, Lace. Look at this. What's this? They won't come over. They're hiding behind Pamela. They're like, no, it's scary smoke and mist, fog. Yeah, you do want to be careful if you have animals and you're doing this. They can breathe it in. So we're going to actually open this door. They were in the back of the house, but now that they're up here, we're going to open it up. But yeah, just so you can see very simply that carbon dioxide goes down, and that's the principle of why this Aqua-Cave works the way that it does. So for all those people that put comments saying, oh, you know, not going to be able to stay in that Aqua-Cave, there's the proof, right, buddy? It's very simple. Just something like carbon dioxide, just like dry ice to show them. Super cool. Let's go open the door so the wieners don't die.
All right.
Go ahead and open the door, buddy. And this would obviously dissipate. Carbon dioxide is really, you know, unless you have a ton of it. Carbon monoxide is much worse. But anyway, isn't that cool? All right, so there's a science lesson for today. That's how the Aqua-Cave works. And we'll see you guys next time.